Hello students, today I am going to discuss few concepts regarding binomial distribution. So first of all, I will be discussing additive property of the binomial distribution. Suppose x and y, two binomial variates I have taken, where x has parameters n1 and p1, y has parameters n2 and p2. So students, we know moment generating function of binomial distribution has the nature q plus p e to the power t whole power n. I mean to say this is the M.G.F of binomial distribution. So what is the binomial distribution for this random variate first one x, that will be q1 plus p1 e to the power t whole power n1, and for y it is q2 plus p2 e to the power t whole power n2, and here x and y are independent in nature. So for that particular property we are having that M.G.F for x plus y is M.G.F of for x into M.G.F for y. So what I have done here, I have just utilized the value of mxt here and value of myt here. But students, we cannot write it here. It is not equal to something like q plus p e to the power t whole power n. Something like this form is not created here. So that is why I am saying x plus y is not a binomial variate, but under certain conditions it will be binomial variate. So what is that condition? Condition is like if the p1 and p2 are equal to p. If p1 and p2 are equal to p, it means q1 and q2 are equal to q. So in that way students, what will be the moment generating function for x plus y? So here from you can write, we can understand q1 and p1 are q and p, so that is what is written. q2 and p2 both are equal to respectively q and p, so that is his whole power q plus p e to the power t whole power n2. So now students, we can write here like this one, this base are same, so powers will be added, so that is q plus p e to the power t whole power n1 plus n2. So yes, we can write it in this form, q plus p e to the power t whole power something is n1 plus n2 here. So that is why we can claim here that x plus y is a binomial variate. In such condition, x plus y is what? X plus y is a binomial variate. Okay, so students, we can generalize it as well. Suppose x1 is binomial variate with parameters n1p, it is x2 is binomial variate with parameters n2p, x3 is binomial variate with parameters n3p, and so on. xk is binomial variate with parameters nk and p. So as per the previous discussion, we can write x1 up to xk is a binomial variate with n1 up to nk and p. Or if I will only talk about two variates, x plus y is their summation. So from this particular condition, we can say that x plus y is a binomial variate when p1 and p2 both are equal. Now students, in order to understand this additive property, I have solved one question which will give you more clarity about the concept. Suppose x is a binomial variate with parameters 3 and 1 by 3. Y is a binomial variate with parameters 5 and 1 by 3. Or I can say x is binomial variate with n1 and p parameters, y is binomial variate with n2 and p parameters. I mean to say n1 is 3, n2 is 5, and probability of success is 1 by 3. So by the previous formula, we can say here x plus y is a binomial variate with n1 plus n2 comma p parameters, and for sure these are considered as independent binomial variates. So students, n1 plus n2 is 3 plus 5, ultimately it is 8. So x plus y is a binomial variate with the parameters 8 and 1 by 3. So our aim is here to get the probability of x plus y which is greater or equal to 1. So students, in order to get this one, first of all we will write here probability of x plus y equal to r. Okay, so since it is following in this question binomial distribution is provided, so I can write it in the for the formula ncx p to the power x q to the power n minus x. So ncx is actually here n is 8. Okay, so 8 cr p to the power r q to the power 8 minus r. and p is also given here. So 8c are 1 by 3 to the power r, 2 by 3 to the power 8 minus r, and r is from 0 up to 8. Now students, in order to find this probability of x plus y greater equal to 1, we can write 1 minus probability x plus y less than 1, and x plus y less than 1 means x plus y is equal to 0. So how I can get this particular value? This particular value I can get here from by putting r equal to 0. So that will be 8c0, 1 by 3 power 0, 2 by 3 power 8 minus 0. Ultimately students, this answer will be probability of x plus y greater equal to 1 is 1 minus 2 by 3 whole power 8. So this is a way to deal with such questions. Now students, if I am talking about next is the moment generating function. It is just a moment generating function of binomial distribution. So students, suppose here x is any binomial variate with the parameters n and p. So we know moment generating function is having this formula, expectation of e to the power tx, and we know how to write the expectation in discrete approach, and here x equal to 0 to n e to the power tx into associated probability mass function. So that is what I have written. So summation x equal to 0 to n ncx, this and this can be written in combined way into q to the power n minus x, or it is like q, it is a formula q plus p e to the power t whole power n. So this is students the moment generating function for the binomial distribution. And if I am talking about the characteristic function of the binomial distribution, then how we can write it? It is just like the formula. This characteristic function formula is expectation of e to the power itx. So again I will be writing here the formula regarding binomial distribution. So expectation will be this e to the power itx into associated probability mass function of the binomial distribution. So this I have written here. So students, again what we can do, we can combine the terms of this one, e to the power itx and p to the power x here. So ultimately it will be creating here q plus p e to the power it whole power n. So this is known as the characteristic function of the binomial distribution. Students, I hope that this video will be very much helpful for you regarding the discussed topic. Thank you so much for watching this video.